Think math.
Here are one day's sales at 3 branches of a cafe. Gangnam sold 120 americanos and 80 lattes. Hongdae, 95 and 110. Busan, 140 and 60. Write those numbers in a single line and it quickly gets tangled. Which number belongs to which branch and to which drink? But put them in a rectangle and wrap it in brackets, and the whole thing becomes one object you can compute with. Why doesn't a single line work? These numbers carry 2 directions, which branch and which drink. Line them up, and one of those directions dissolves into the ordering. You can see that 80 follows 120, but you cannot tell whether that is a different drink at the same branch or the same drink at a different branch. 2 directions of meaning need 2 directions of position. So we use across and down. A line going across is called a row, and a line going down is called a column. Put the branches along the rows and the drinks along the columns, and every number lands in its own place. The 95 in the second row and first column is Hongdae's americano. The position tells you the meaning. This table has 3 rows and 2 columns, so we call it 3 by 2. Now, the decisive step. We wrap the table in brackets and give it a name. Let's call it capital A. It is no longer 6 numbers. It is one object called A. An array of numbers laid out in a rectangle and wrapped in brackets is called a matrix. Each single cell is called an entry. Why is wrapping such a big step? Giving a number a name lets you add it and multiply it. Giving a table a name lets you add and multiply the whole table. Call this month's table A and last month's table B, and the 2-month total is just A plus B on one line. One line instead of 6 separate additions, treating a table as if it were a single number. That is the new world a matrix opens. 2 directions of meaning need 2 directions of position. The moment you wrap it in brackets, a table behaves like a single number. A sip of math every day here at Think Math.